শুনতে খুবই অদ্ভুত লাগছে, তারপরেও দেবে না।
কেন?
রেকর্ডিং অন করে দিয়েছি, চল।
ডিভাইস থেকে পারমিশন দেবে না। জুমটায় ওরা ঝামেলা করবে না, কিন্তু গুগল মিটটাই করবে। মানে আমি এখান থেকে জয়েন করলে আবার ল্যাপটপ থেকে ঢুকে রেকর্ডিং করতে হয়। হুম। লেট Rahul, what has been the notation? Are we taking A to be the ring or R?
এই
Hmm. So what is the property? The property is given in a module P and in A bilinear mapping if M cross N to P, there exists unique A linear mapping F prime that is from T to P such that so you see we are talking about this diagram to be commutative. Remember, this map is bilinear and this map is linear. Once we write down this statement, we will take a look at, I mean, what it says exactly. Moreover, if TG and T prime G1, clear? Clear? Now let me show you the statement. I'll give you a minute. See this, then I will move on. So all of this is taking place inside a collection of A modules. Okay. So A, main, P, T, whatever there is, those are all of these are A modules. Okay. The ring is constant. অদ্ভুত তো। হ্যাঁ, আজকে হবে না, কালকে করবো। হলো?
হ্যাঁ।
হুম। So the last property says this thing is unique up to unique isomorphism, right? Not only T and T prime are isomorphic, there is an unique isomorphism via which they are isomorphic. Like, I mean, there can be more than one isomorphisms between two objects, right? but this is much stronger. They are unique up to unique isomorphism.
What is a bilinear map?
What is a bilinear map?
Yeah,
So you know that a bilinear map is like this. So G A comma M comma N, it is supposed to be G M N, right? This scalar. Now, where should this scalar come from? This is coming from a ring or a field. This
yeah,
ring or a field is A in this case. You have heard about R linear maps, right?
yes, yes.
Or C linear maps, right? A map might be C linear and may not be R linear. Sorry. A map might be R linear and might not be C linear. So just like that, the map will bring out some scalars from the bracket outside. Okay. Hmm.
But here it is bilinear.
Yes. So you don't know what a bilinear map is?
Yeah.
Okay, fine. Let's write it. So G is bilinear if G is linear in both the coordinates. Mara clear?
Yeah, yeah.
It is clear. It has to be in both the coordinates. Okay, linear. So, hmm. Now see, I mean, we have defined something. So the bare minimum is we have to show that the set is non-empty. Else we can define everything, right? We can define everything. But once we have given a definition, the very next thing we need to do is to show that such a thing exists, right? So that part is constructional. You will have to construct. So let's start. And this is a big construction. We don't know whether we can complete it in one class or not. I will try. Do you know Nakayama? Sorry. Do you know snake lemma? Do you know snake lemma free modules? Do you know it? अरे बोलो नाहले I'm not asking him individually. Has this been taught in the class? Else I will have to teach them.
It was not taught in the class.
You don't know snake lemma free modules?
Yeah.
Free modules you know, no? Okay, fine. Yeah, I need free modules only. Okay.
Snake lemma is not required.
Snake lemma is not required, but I mean it is required not to prove the tensor product, but for the course. I mean, if needed, I will show it. Okay.
Ah,
Good. We consider that is by this. What do we mean? That is consists of all formal final linear combination. Do you understand? What does it mean? How will it look like? Do you understand? So you see, so an element
So A1 M1 plus A2 M2, A1 A2 belongs to A. M
yeah,
M
sort of. I mean,
sorry A1 M A2 M N. This type of linear combination.
hmm, exactly. So you see, I mean, you will probably get something like this. I mean, like Rahul was saying, elements of this type, mi, comma ni, okay, sum over I, where this sum is finite. Okay, understood what I am saying?
Yes.
But let me ask you something.
Yes.
So Madhav, you understand how the thing, how the elements look like?
Yes, yes.
These are symbols, you understand? I mean, if say I take m
Mm-hmm.
comma n and m prime comma n prime, we are just putting them together with an added sign. Okay. So question: do we have m? mm, Maybe I should write with x. Do we have x plus x prime comma y is equal to x? Do we have it? Okay, maybe I should write a few more things.
Yes.
Just a moment. Just a moment. X comma y plus y prime is equal to x comma y plus x times y. I mean, you can understand x prime is in m, y prime is in n, and a is in n. So, Madhav, do we have these relations?
Yes.
Anyone else apart from Shomallo?
I think no.
Hmm. Right.
And we
We
have to
have
make it so.
exactly. We have none of the above. Madhav,
Because it's a free model, there's
we
no
are
limitation.
not Madhav, you understand, we are not talking about the product module m cross n. Okay,
Yeah, yeah.
maybe I should write like this with a red. There's a common misconception. We are not talking about m direction n or m cross n. We are inside a to the power m cross n, okay, which is a different beast altogether. So, I mean, a priori, you don't have those things. But as you can see, we need these relations, right? Otherwise, what should we do? I mean, how should we work with this? These are very basic facts. I mean, we will need those things to happen inside our object. So, Madhav, suppose you don't have an equality in a module or a group, okay? You don't have those equality, but you want them. What should we do? Hmm. Can you tell me what is the next trick? So we don't have it a priori. So what? But we need them. So what should we do?
We define the equivalence relation.
Exactly. Hmm. Inside a to the power m cross n, take the submodule D generated by the following relations. Right? So you see, these are our relations, okay? So basically, we have taken all the pairs and we have taken these relations, okay? So D is generated by all those relations. Clear? Define T to be A to the power m cross n quotient. Clear? So you see, we have, I mean, in their image, we have the equality, right? Because one bar, you see, like, so one bar, that is zero, right? In D. Similarly, two bar, zero. So the image of these elements, this type of elements, they are zero in T, right? Now you have the equality. Clear? So you have the equality in the quotient module, right? But you see, we have only constructed T. We will have to show that G is bilinear. Okay? We haven't yet shown it. We'll have to show G is bilinear and then the universal property. Let me see how far we can go. Claim So what was the map? The map m cross n to t has to be bilinear. So what will be the image of this map? It will be m comma n going to m comma n plus d. So g of x plus x prime comma y is equal to
हाँ ये
what?
तो बाय
By
डेफिनेशन.
our, yeah, according to our definition, I will just check one plus d, right? Now you see one bar is zero, right? What was one bar? This thing is one bar, right? So this element plus d is equal to this element plus d into this element plus d, right? So this is nothing but x comma y plus d plus x prime comma y plus d. That is gx comma y plus 0. Okay. Similarly for the other coordinates. Similarly, you can check 2, 3, and 4. Okay. Mhm. Now the universal property, right? Given any module P, so see, we have come this far, okay? Now the next thing, that is, given any A module P and any bilinear mapping F M cross N to P, we will have to construct an F prime such that the diagram commutes. Let's copy this. Let's copy this diagram. By the way, this second property is called the universal property, okay? So for the time being, we don't have this. So we don't have this for the time being, okay? And we will define if in a very obvious way, right? So again, define f prime t to p. So these are the elements in t, right? They will go to what? Right? Because you will have to make the diagram commutative, na? There is only one way. Okay? But you see, if prime has to be linear, right? Is f prime linear? Yes. So But first we'll have to check that whether is f prime is well defined or not. Okay. So if x comma y plus d is say n comma n plus d, then we have x comma y minus m comma n to be inside d, which imply f of x comma y is equal to f of m comma n. Okay. So f is well defined. So claim f prime is a linear. Okay. So the now the linearity. Okay. Okay, maybe I need to show you that why this thing happens, right? I mean, why is it? I mean, why is the above term zero? Okay, let's write a little bit. Not an issue. Since f is bilinear, you see all these relations hold when applied with f, right? So from this we can say that f sends d to zero, right, Madhav? From the bilinearity of f sends whole thing to zero. So f will send this to zero as well, right? So f of x comma y minus m comma n, this element is will go to zero, which imply f of x comma y is equal to f of m. Okay, so f is well defined. Sorry, f prime is well. So you see, we already have an f prime, right? And we already have the commutativity of the diagram. Only thing we'll have to show that f is linear. Okay. So suppose if prime say a times x comma y plus b is equal to what? This is f prime ax comma y times d, right? All these relations equalities. So this thing and this thing are equal quotiented out by d. I mean in the quotient module, that is, I mean, which imply, and what is this by our definition, right? And since a is bilinear, correct?
Yes.
And you see, I mean, the way we have defined it, it is clear that it is bilinear, na? Because what are we doing exactly? We are taking m comma x comma y from there, okay? We are sending it to x comma y plus d, and there, I mean, and it is also coming to fxy by f, and we are sending this element by f prime to the exact thing. I mean, we are sending it exact here, right? Exactly, just to this element. Thus we, so there exists f prime. We don't know about the uniqueness yet, right? But there exists an f prime. By definition. Now again, uniqueness. So let f prime compose. So first we are saying that f prime is, I mean, from t to p, t is fixed here. Okay, so t is fixed. We will show that from t to p there is only such map. I mean, only one such map. That is f prime. And then we will talk about the uniqueness of t prime and t and g, right? So for the time being, we are not talking about this uniqueness. Okay, not about this weak uniqueness. No, we are not talking about this uniqueness here. Okay, we are talking about uniqueness of, where did it go? Yeah, we are talking about uniqueness of f prime here. So you see, if f prime satisfies the same property, if should happen like, we should have, right? Now then we have f of m comma n is equal to f prime compose g of m comma n, right? Which imply f prime of m comma n, you see under the map g, right? So we have this equal to m comma n, right? But that is exactly what f prime of m comma n plus d is, right? So we have f prime is equal to f double prime, right? F prime and f double prime match at every element. Madhav, is that okay?
Yes, yes.
Hmm. Now the next uniqueness. Let That one definition thing is going on. We have started 40 minutes back. Be another pair with the same. Okay. Okay. Now look at this carefully. Okay. I will dot two diagrams and you look at it very carefully. So in this diagram, considering you see here, okay, considering t prime equals to p and t to be the tensor, and in this diagram we consider t equals to p, p equals to p. Right, Madhav?
Yeah.
Thus we have these diagrams, and here you have, I mean, with this commutativity, I guess you have G prime is J compose G, I believe, and here you have G prime, sorry, G equals to J prime compose G prime. Uh, সুব্রতা ঠিক লিখেছি? J compose G equals to G prime, yeah, correct.
Hmm.
Hmm. I need to dot two more diagrams. So you see, we have
Yeah,
two
you can just
relations.
compose it to.
Yeah. That's what I'm going to do. So, what was J by the way? G prime. So, you see another diagram I'm drawing. So between t and t prime, you see here we have two things. I mean, we let me draw a box here. So G prime is G compose G, J compose G, which is J compose what? What was G? Which is J compose J prime compose G prime, right? Again, G equals to J prime compose G prime, that is J prime compose J composition of G. Okay, right? So you have these two relations. Call it star and call it double star. Okay. So G prime is star. Okay. So here you have J compose J prime. J compose J prime. I mean, I should write it here. J compose J prime. Star, I believe it was. By star, I believe it was. So G. Am I writing it correctly? I have a doubt. J prime compose J should be there. Sorry. Okay. So you see, J compose J prime, this map is from T prime to T prime, and similarly J prime compose J, this map is from T to T, right? And we have these two conditions. Okay. But you see, as we have mentioned time and time again, whenever you have this sort of diagrams, this map is supposed to be unique, right? Whenever you have this sort of diagrams, this map is supposed to be unique as well. So what do you get? You get, in this side you get, and in this side you get.
So
Clear?
J compose J.
একদম. So unique up to unique isomorphism. Okay, we have established it. From T to T prime, the map was probably J, right? From T to T prime, it was J, no? From T to T prime. Okay. So unique up to unique isomorphism. Now the notation. We denote this T by okay, and m comma n plus d belongs to T is denoted So when we are writing elements, it is enough to write just the tensor sign. When we are writing the tensor sign between two modules, it is important to mention the ring the tensor has been taken over. Clear? So in tensor A to N, we have m plus m prime tensor N to be m tensor N plus m prime tensor N in tensor N plus n prime is m tensor N plus m tensor N prime. Clear? And is it clear?
Yes.
Hmm. So we'll have a few more things to go through, which we will do in the next class. But let me just check out. So we will talk about the property. So in the next class, we will talk about the adjoint properties of Hom and tensor. I think that's something we should talk about. Hmm. So next class, properties of tensor, adjoint property of Hom and tensor. Okay. So that's what we will look into in the next class. Okay. Hmm. So, Tata. Okay, that's it for today.